Currently, if we want to find the derivative of a function, we need to use the definition of the derivative. This isn't that difficult if we are looking at a linear or quadratic function. But what happens if we have something much more complicated, like a polynomial of degree 9 with 8 terms? The definition of the derivative will still work, but keeping track of terms will quickly become difficult. Fortunately, there are some rules that make it easier to differentiate certain expressions. The first rule we'll look at is the constant rule. For any constant c, the function f of x equals c is a horizontal line. The tangent to any point on a horizontal line is also a horizontal line, and the slope of a horizontal line is 0. Therefore, the derivative of the constant function is 0. This can be written as either f prime of x equals 0 or d over dx of c equals 0. Now let's try an example. Find the derivative of f of x equals 25. Since 25 is a constant, we can use the constant rule to find the derivative. Using the constant rule, we find that f prime of x equals 0. Now let's look at another rule. If f of x is a monomial with a coefficient of 1, we can use the power rule to find the derivative of the function. F of x equals x to the n for any positive integer n. The derivative of the monomial can be written as f prime of x equals n times x raised to n minus 1. It can also be written as d over dx of x to the n equals n times x raised to n minus 1. Now let's find the derivative of the function f of x equals x to the 100th power. Start by finding the derivative. D over dx of x to the 100th power. Using the power rule, the derivative is equal to 100 times x raised to the power of 100 minus 1. Simplifying the exponent, we get 100 times x to the 99th. So, f prime of x equals 100 times x to the 99th. So far, we have seen rules that make it easier to find the derivatives of constants and monomials with a coefficient of 1. This still doesn't help with that polynomial of degree 9 with 8 terms we thought about in the beginning, if any of its terms has a coefficient other than 1. That's where the constant multiple rule comes into play. Given two functions f and g, where g of x is the product of a constant k and f of x, then the derivative of g is the product of k and the derivative of f, which can be written as g prime of x equals k times f prime of x, or as d over dx of k times f of x equals k times d over dx of f of x. Let's put the constant multiple rule to work and find the derivative of g of x equals 5 times x to the 6th. Start by finding k and f of x so we can use the rule. Here, k equals 5 and f of x equals x to the 6th. Using the power rule, we find that f prime of x is 6x to the 5th. Now substitute these values into g prime of x equals k times f prime of x to get 5 times 6x to the 5th. Simplifying this results in 30x to the 5th. Therefore, g prime of x equals 30x to the 5th.